PLM, SLM, database, graphics, communication, etc. Enable large teams to collaborate and manage changes, because especially aerospace and defense industry is a very large, not company, but environment, because there are many companies, as I said before, that one time can be competitors, one time can be allies, that are working together. It's a Facebook-like, let's say, social example, where something is controlled, but not too much is enough to control it to do things, and large teams can collaborate and manage changes together. So internet connectivity is the backbone, and a unified system development platform to test product independently if real test or virtual test is under development. So let's say go beyond email and document sharing. And again, intelligent. So follow the right process. So workflow process library available, new customizable workflow easy. Drive what to do. So to do the next action. Measure immediately the effects on the model and get functionality feedback. Tracking change, communicating business relevant milestones, not only engineering or business milestones. So intelligent and also expert. So is able to capture the user intention, to use previous experiences, and also to optimize. That is the final step in this process, but it's a very important step. And easy to use, this seems simple, but again, in the engineering simulation, we are not still at the point where everything is easy, because the matter is not easy. Modeling and simulation tools oriented to the human being. Interface needs human focus, visual, memory, physical hardware solution capability, and to speed up, more faster. This last point. And simplify also the management work. Manager needs a synthesis of the engineering info, not only the engineering info to take a decision. Most of you, many of you, know very well this point, because every day we face this problem. For us, everything is very clear, but when we talk with the manager says, I don't understand, I need to simplify, yes or no, black or white. That's the point. So to provide synthesis of engineering information for the business decisions. It's clear that the direction is definitely toward virtuality, cost less. It can always be done. For example, in a critical path, I don't want to mention space application where we know very, very well that some kind of test cannot be done real. You must do in a virtual environment, because you cannot test 10 times how to get on the Mars, on the Moon. Or the same thing when you have some test to do where you risk to, let's say, lose a part of the model, the real model, that is the human. So we try to avoid this situation. And now also much more tests. Yesterday we said that one of the things that can be addressed by simulation was the reparto sperimentale di volo thing that so an official of the technical side of the time before say we can reduce the risk thanks to the fact that we can do much more tests. And needs to be used together, both the real, the geometric virtuality in PDM, PLM, with the testing tools. That means again, real test or virtual test. Gathering a lot of data. This can be used to support engineering and business decision, and goes toward the virtual user product. So let's say we already see this kind of virtual user product. Maybe our childs are working with the flight simulators every day, but the only difference is the flight simulator today is just using data to see where I'm going in a turn, in a pitch or something like that. But it would be much better if we can use the virtual model that is real physics behind that, something that we're already doing, for example, in automotive. So this virtual user product is driven by humans, piloting virtual models, moved by simulation concepts. Just following, as I said, technology and application paths already experienced in other fields, in terms of virtuality. So, which is the summary we can get in terms of business improvement through simulation. First of all, system engineering focus. Now I think that this point is pretty clear that are going to converge. I would say simulation is going to converge towards simulation engineering, system engineering, because it requires some modeling simulation background, through virtual prototyping. So the real prototyping is still important part, as we said also yesterday with authorities, but also the virtual prototyping is much more powerful if we are able to be compliant with the rules and aligned to the real physics. Product architected approach, so from the top to the bottom or vice versa, at different level in the BIM model, leveraging functionality and performance view of the product, not just geometry. Capability and power to simulate complete physical phenomena through right software, algorithm, and hardware power. Engineering business intelligence at the end, on the top, leveraging the huge performance database available, and the simulation technology knowledge that already has been applied, for example, for the physics, but can be applied, maybe just a part of that can be efficiently applied also for business intelligence. And in general, empowers innovation through technology and people. So, just as a last slide, I think that many of these fields have already been seen and been faced in the past 15, 20 years, more or less. Most of these topics have been already afforded, but what we need to do is to try to get to simplified use of the virtual model as in the test with a synthesis of the information for the manager and for the business. Thank you very much, and I move the word now to Alessandro Franzoni, that is one of the players of this conference, and is also the coordinator of the activities in Aeronautica. And by the way, we worked since a long time in this kind of topic, so I'm very pleased that Alessandro is here, and I think that he can testify what the company is looking for and how the company is looking to this conference.